Hello everyone. Today we'll talk about initialization, which is done by the initializers. An initializer is a block of code that is executed right after the object is created. And similarly, we have deinitializer, which is the code that's executed right before the object is destroyed. Class, struct, enum all have initializers. Here we have an example of class vehicle, which has the var property current speed, a constant property name, another property description, and color is an optional. And then we have an initializer for the class vehicle. One of the main purpose of an initializer is to initialize the properties that haven't been initialized yet. So inside the initializer, we initialize the value of current speed, name, and description. And if I leave one of the properties not initialized, then the code won't compile because you cannot construct an object with its property not initialized. However, the initializer is not the only place a property can be initialized. You can also initialize a property over here. And now if I comment out this line, it's okay because current speed is initialized already. Another thing to note is that color is an optional. And as we talked about before, an optional is initialized the moment it is declared. So over here, color is already initialized, and you don't have to initialize an optional inside the initializer. Also note that the name is a constant property. But inside the initializer, you can change the value of a constant property. For example, name equal to empty string. This is the only place a constant property can be changed. Nowhere else you can change a constant property, not even in its subclasses init function. And here we have another init function which has two parameters, speed and name, and all the properties are initialized based on the value of the two parameters. And here we do let v1 equal to vehicle. This is calling the first initializer. And let v2 equal to vehicle speed 23 name car. This is calling the second initializer. And note that when you call the second initializer, the parameters all have external names. But the initializer doesn't define an external name for the parameters. So this is another rule which says all the parameters of an initializer have default external parameter names, which are the same as the local parameter names. Now we have encountered all three cases where a parameter has default external parameter names. The first case is a function parameters that has default values. Second one is all method parameters except the first parameter. And last one, all initializer parameters. One nice thing about the initializers is that you don't always have to define the initializers by yourself. As long as you satisfy certain condition, the compiler can generate the initializers for you. For example, we have a class dog which has a property age and a name, and then we can do let d equal to dog. This is calling the default initializer, and the default initializer is generated by the compiler. You'll get this default initializer for free as long as you satisfy two conditions. Number one, all the properties are initialized. So here both age and name has an initialization value. And number two, no init function is being defined for the class. And then you'll get the default initializer for free. And this is true for both class and struct. But Enum doesn't have this auto-generated default initializer. Struct has another auto-generated initializer, which is called member-wise initializer. Here we have a struct cat, which also has an age and name, and then we can do let c1 equal to cat age2 name will. This is a member-wise initializer that's generated by the compiler. And you'll get this initializer for free as long as no initial function is being defined. So even the age doesn't have a initialization value, you still have this initializer. However, in this case, you will not get the default initializer. If you want the default initializer, you have to provide an initializer value for every property. As we have talked about before, the biggest difference between a class and a struct/enum is that a class supports inheritance, which means the init function of class has another important job, which is to call the superclass's init function. Here we have a class vehicle2, which has an init function that does the initialization for all the properties, as always, and then it calls the superclass's init function. For class, an init function that does both things are called designated initializer. Every class must have at least one designated initializer, whether that designated initializer is self-defined or inherited or auto-generated. What's important is a designated initializer must initialize all of its own properties and call its superclass's init function if it has a superclass. All other initializers are called convenience initializer. A convenience initializer finishes its initialization job by calling other initializer in the same class. And that initializer may be calling yet another initializer, but ultimately it must finish these two jobs, initializing all properties and calling the superclass's init function. Note that the concept of designated initializer and convenience initializer only exist for class. Struct and enum don't have this concept. When you implement an initializer for a class, the things that the initializer does need to happen in a fixed order, which you have to remember. First, let's look at a designated initializer. Step 1 is to initialize its own properties. Step 2 is to call superclass's initializer. And step 3 is to override superclass's properties and or its own properties. These three things have to happen in this order. For convenient initializer, step 1 is to call another initializer, and step 2 is to override properties, both for the superclass and for itself. This kind of ordering is enforced by the compiler, so that your class has more consistent behavior. And you need to be careful when you are calling a method or accessing properties from inside the initializers, because depending on the places where you are accessing these members, the result may be different. The book divides the initialization process into two phases, from start to the point where all the superclasses init functions are called belongs to the first phase, and the rest belongs to the second phase. And it is recommended not to call the methods and access the properties during the first phase, because you cannot guarantee that all the properties are initialized during the first phase. So this is the second phase, and this is the second phase. You should be able to do anything in the second phase. Now let's talk about the deinitialization. Every object has one or more initializers, but has only one deinitializer. And here is the signature of the deinitializer. A deinitializer is called right before the object is destroyed, and it is always called automatically. You cannot call the deinitializer explicitly, such as this. A superclass's deinit function is automatically called at the end of the subclass's deinit function. And in the deinit function, you are free to use any methods or properties, because the object is not destroyed yet at this moment. You can assume everything is still intact. Now let's talk about the enum. Enum can has an initializer, as we talked about before. And the enum's init function requires you to assign a value to self. So this is a required assignment. And that's the reason why the enum doesn't have automatically generated initializer. If I comment out this initializer, you cannot construct an enum through the default initializer. As we talked about before, struct and enum doesn't have the concept of convenient initializer and designated initializer, but they do have the concept of delegate initializer. In this example of the enum, it has two initializers, and one initializer is calling another initializer for the initialization process. This is called initializer delegation. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.